Okay, one more video on function inverses. So this is where if you're asked to prove whether or not two functions are actually inverses of each other. Okay, so your objective is to prove that they're inverses or not by using composition. So if you're given f of x and g of x, they're going to be inverses of each other only if when you compose f of g of x, you get x, and you have to prove that g of f of x gives you x. Basically, what you put in is what you get out. So all we're putting in is x, and what I get out, everything cancels, and all that I'm left with is x. Here, x is going in, x is what comes out. So everything cancels, and all that you're left with is what the original value that you put in was. Okay? One of the examples from your assignment says, oh shoot, let me find it again, sorry. Prove where did it go? Gosh, dog it. Okay. So, our g of x and f of x inverses. And you're given that g of x is negative 4x and f of x is negative 6x minus 1. Okay, one quick note. Yes, these are tedious problems. You have to do a lot of work to prove it algebraically. You got to do composition 2 times. But it is not hard work. It's just tedious. Okay? And one thing to remember is we're talking about inverses. So whatever I see happening in this function, I should be seeing kind of the opposite things happening in this function. So when I look at this, I see that I've got a negative. Well, the opposite or inverse of that would be a positive. I see that I'm multiplying. Negative 4 times x. So the inverse of that would be dividing. So when I look over here, I see negative here, and I still have a negative here. So that one didn't swap. This has subtraction, which would mean that there should have been addition here. There's not. Okay? And then multiplying by a negative 4, I should see dividing by a negative 4. I don't. So intuitively, I'm thinking to myself, no, these are not inverses. Okay? But I have to prove it. To prove it, we must do these 2 steps. Okay? So, step 1, I'm going to go ahead and do f of g of x. Remember, all this means is plug g of x into f of x. And we're hoping that what we get out is just x. We want everything to cancel, proving that there's inverse operations happening. Okay? So, if I do f of g of x, then that means I'm doing f of, and what I'm plugging into f is g of x, which is negative 4x. Okay, well, f of x says negative 6 times x minus 1. So it's negative 6 times g of x minus 1. And again, g of x was negative 4x. Okay, do the math. Negative 6 times negative 4 is 24x minus 1. That is f of g of x. There is nothing else I can simplify. Okay? Do I have only x left? Hopefully you're saying no. I've got 24 times x and then minus 1. That's not just x. So already we know this is a no. They are not inverses. Okay, let's try one where they are inverses. I'm going to pause for a second. Okay, next example. Prove they are inverses. H of n is 2 over 9 times n plus 10 over 9. F of n is negative 5 plus 9 over 2 times n. Again, kind of glance at it and see. This one has addition. This one has a negative or subtraction. This one has 2 over 9. This one has 9 over 2. I'm already seeing inverse operations. So I'm hoping that, yes, these will be inverses. But to prove it, I have to do composition both ways. So I'm going to do h of f of n, which means I'm taking f of n, this whole expression, and plugging it in for the n in H right there. So all of this goes in right here. Okay, so what that means is the 2 over 9 stays the same from H. And then instead of this in, I'm plugging in f of n, all of that. -5 plus 9 over 2 in. Then go back, and h of n also had that plus 10 over 9 at the end, so I got to keep that there. Now all I'm doing is distribution. When you're multiplying fractions with a whole number, multiply the top, divide by the bottom. So I've got 2 times -5, that's -10, and that's divided by 9. I'm just going to leave that as a fraction, -10 over 9. Okay? When I go here and multiply, again, this is multiply by 2, then divide by 2. Those guys cancel. Multiply by 9, divide by 9. Those guys cancel. All that's left is the n, and it's positive. Plus n, then drop down the dude on the end. And hopefully you guys see what's happening here. I have a -10/9 and a +10/9. They're going to cancel. So my final answer here is n. Remember, that's what we want. Whatever we plugged in is what we get out. Plug in an n, get out an n, nothing extra. So that checks out. But in order for them to be inverses, I have to do both ways. So now I have to do f of h of n, which means I'm plugging h of n into f, where the n is. So in f, my n is at the very end. Instead of it just being n, it's going to be this whole expression. So what I'm doing is -5 plus 9 over 2 times, instead of just n, I'm plugging in h of n, all of that. So it's 2 over 9 times n plus 10 over 9. All of that gets plugged in, so all of that goes in parentheses. Start with your distribution. So the -5 is still there in the front. Now, 9 times 2, and then dividing by 9 times 2. Everybody cancels out. Just gives me an n. Here, the 9 and the 9 cancel out, so I end up with 10 over 2 left. Hopefully you guys know what 10 over 2 is. -5 plus n plus 10 divided by 2 is 5. What do we see happening there? A negative and a positive cancel, and I am left with just n. So I got n here, I got n here, did composition both ways. What does that prove? That, yes, they are inverses. Okay? Alright, I hope these videos help. I'm going to get them posted just as quickly as they load to YouTube. So when you're seeing this, I really, really hope it helps you. Alright, later.